All right, for part B, let's see what we have. So we have 2n as a number factorial, x to the power of 3n divided by n factorial. As I said, ratio test is one of the best tests to apply towards power series. So that's what I'm going to do. I'm going to apply the power series for this problem for a n to be equal to 2n factorial x to the 3n divided by n factorial. As I said earlier, so x is a variable here, and my goal is to find a good interval for x coming out of this analysis. Okay, so the absolute value of a n plus 1 over a n in this regard is going to be, let's just write it, 2n plus 2 factorial x to do 3n plus 3 over n plus 1 factorial. And I'm just going to copy this down here. And this is a n, so a fraction divided by another fraction. Well, I'm gonna flip the bottom out. In fact, flip the bottom over, right? Factorial x to do 2n plus 3 divided by n plus 1 factorial times n factorial, okay? Divided by 2n factorial x to do, this is 3n by the way, 3n. Okay, let me just clean that up. All right, and I should have the absolute value sign here. All right, what I'm going to do next is to use the properties of factorial and the exponential numbers here. So here we go. So 2n plus 2 factorial is 2n plus 2, 2n plus 1, times 2n, 2n minus 1, and so on, but that's 2n factorial, right? And x to the power of 3n plus 3 is x to the 3n times x cubed. Okay, let me just, I don't want to mess this up. X to the 3n x cubed, okay? All divided by n plus 1 factorial is n plus 1 times n factorial, okay? N factorial to n factorial x to the 3n. Okay, let's see what cancels out. Well, 2n factorial cancels this 2n factorial. X to the 3n cancels this x to the 3n. N factorial cancels this n factorial. So at the top, I have 2n plus 2, 2n plus 1, and x cubed. In the bottom, I have only n plus 1. All right, so I rewrote what we were left back here. Okay. So what I'm going to do next is to see what's going on here, because what is like a n plus 1 over a n in terms of its limit, right? Because I have to pass the limit here. Okay, so let's just copy that down again here. In the previous part, I did not pass the limit because I didn't need to, because there was no leftover n term here. So the limit of that quantity is just 3x, the absolute value of 3x. So I sort of like didn't do the limit calculation, but for this one we had to see what's going on in terms of the limits. Okay. Well, first of all, x is a parameter. X is just a parameter that I am supposed to determine. So this limit is governed by n-related terms because the limit is on n. So n-related term is this one and this one. Okay. So the top is a quadratic. The bottom is linear. So that term, like that ratio, all together is going to go to infinity, unless x is 0. Right. If I choose x to be 0 for x specifically to be equal to 0, okay, so this limit is going to be 0, okay, limit of a n plus 1 over a n is equal to 0. And any finite number that I pick for x, like 1, 2, 3, 4, 5, is going to make this limit going to infinity, and when the limit is greater than 1 or infinity, the ratio test says like it's divergent. So for any other x, okay, this limit is infinity, okay. The ratio test says like it diverges for any other x. In other words, the power series diverges. The power series converges only for x equals 0. Okay, so here only x equals 0. This series is convergent. So essentially, only at the center of the power series it's convergent, and for others it's not. So essentially, I have to exclude all of this, right? Only x equals 0. So the radius of convergence in this case is just r, because I can't really move to the left, to the right, because I put myself into the divergence zone. So for that reason, r, the radius of convergency, is going to be 0. And if you want to talk about the interval of convergency, there is no interval to talk about. It's just a point convergency. So this function, in other words, is convergent only at x equals 0. And for any other x's, the infinite series is going to diverge. All right, this is the end of the video. Thanks for watching. I'll see you in another video. Bye.